Okay, so we're going to look at a couple of examples that show up in one of the lessons here. We're dealing with the first fundamental theorem of calculus. And so let me just go ahead and remind you what that states. We know that if we are finding the derivative of the integral from a to x, we've got some function here, f of t dt, okay, then we know that what this is equal to is f of x. Now, in one of the other videos, I showed, what's the graphical implication of this. This part in here, f of t is just some function. This integral right here would be the area under that function going from some constant over to some variable x. And if I drag x one way or another, then that area changes. And so what we're actually doing here is we're looking at the rate at which that area is changing. And we say that, okay, well, that rate is actually equal to the height of the function at x. And so that's what the first fundamental theorem of calculus states. So we're going to look at a couple of examples here. The first example is where we are going to go in here and just say, let's find g prime of x, where we know that g of x is defined as it's this area that goes from 1 to x of this function, 1 over t cubed plus 1. Okay, so we know that this is just going to give you some graph. We are looking at the area that goes from 1 up to some x value. And so whatever that area turns out to be, that's how we're defining g of x. And so we want to find the derivative of this. Well, I think it's not too hard to see that, this is exactly just the first fundamental theorem of calculus. We're going from a constant to x, just like we are right up here, a to x. We've got some function here involving t. We're doing this integral, and we want to find the derivative of this with respect to x. And we're asked to find g prime here, which is the derivative with respect to x. So all we have to do here is just say, well, what is this inside function here? What is this f of x here? And plug x into it, and we got it. So just by the first fundamental theorem of calculus, the answer here is just going to be 1 over x cubed plus 1. And that's really just sort of recognizing that this is exactly in the form that we want it to be in. So, okay, we got that. Not a big deal. So let's look at another example then. And here we're going to, well, it's going to look pretty similar. We're going to find capital F prime of x. And here, capital F of x is going to be an integral. We're going to go from 1 up to something up here. Now, in the previous example, we just had an x right here, but this could actually be some function, and actually so could this down here. But I'm just going to say, well, what about if we're going up to square root of x? And we need a function here involving t, so let's say sine of t dt. So we see that things are a little bit different here in this problem. We first of all, we see that we're going to some function of x up here. Okay, so what are the implications? What does that mean? How do we do things differently here when we have this? It almost looks like what we need here to use the first fundamental theorem of calculus, but not quite, because this here is just a single x all by itself. So what difference do we have if we have a function of x right here? Well, I'm going to remind you of something real quick. Let's just go off to the side here for a second. And I'm just going to remind you of, let's just look at sort of like a real simple problem. Let's say, suppose that I had some function here. I don't know. Let's say we had, let's just say that we had 2x plus 3 raised to the 5th power. And I was trying to find the derivative of that. If I was trying to find the derivative of this, let's remember what we would do. We would say, hey, I've got an inside function here, and that's thrown into some other function. And when I do the derivative here of this, I would take the derivative of the outside part, and so that would be subtracted down to 4. And then I would multiply by the derivative of the inside part. And the derivative of the inside part here would just be, well, that looks like we would get an extra 2 showing up right there. And so that's the chain rule that we're using here in this case. We got an inside function, we got an outside function, do the derivative, we do the derivative of the outside part, and then we multiply by the derivative of the inside part. Turns out we're going to do the same type of thing right over here. All right, we're going to go in here, we're going to say, hey, let's let u equal the square root of x, which I'm going to go ahead and write as x to the 1/2. Okay, so u is equal to the square root of x. And what that allows me to do is go over here and rewrite this function over here. That means that capital F of x is equal to the integral from 1 to u of sine of t dt. Now remember that the sine of t is just a dummy variable here. I don't really care what it is. This is just sort of representing what is that function that we're finding areas under. So you know, this up here, the fact that I put a u here instead of the square root of x doesn't affect this function over here at all. So I've rewritten my function this way right here, and we're remembering u is a function of x. You know, now that I've written it like this, you can see that that's very similar to the first fundamental theorem of calculus. You know, if I'm going to go in here and do this, all right, fine, I should be able to sort of do this. I'm going to take the derivative with respect to x. I've got, you know, an x up here, but I'm just putting in a u here. I'm putting a u right there. And what that allows me to do is allows me to just sort of use this first fundamental theorem of calculus. When I find the derivative here, well, this is really just going to be now sine of u. But I got to remember, hey, that's sort of like that outside function part, right? That's the derivative. But I've got to remember, u is a function of x. And so if I find the derivative here of this thing with respect to x, then just like I had to multiply by the derivative on the inside over here, I'm going to have to multiply by the derivative of the inside here as well. The inside function being u equals x to the 1/2. So I'm going to have to multiply this thing by u prime. So what I get is I've got sine of u. And u prime, let's see, I should be able to find that. Looks like that would give me, what, 1/2 x to the negative 1/2. And because I want this function to be in terms of x, I'm going to go ahead and, you know, replace my u. So it looks like I end up with sine of the square root of x, right? I just put in square root of x where the u is, because that's what it equals up here. Looks like I could probably do some things over here to clean this up some. First of all, I've got a 2 in the denominator. And that x to the negative 1/2, so that means that thing comes downstairs. And I guess if I want to write them all in terms of radicals, I could rewrite this as sine square root of x over 2 square root of x. And I've pretty much got it at that point. Okay, so that's how we can do that. You know, sometimes we throw different functions in here for these limits. When I do that, I've got to remember I can still use the first fundamental theorem of calculus, but I got to remember that that I've got to throw the chain rule in here as well. And in particular, I got to remember to multiply by the derivative of that inside function at this stage right here. All right, I hope that's been helpful.